Hi everyone. It's nice to see you in this video. Today we'll dive into some powerful advanced date and time functions in Excel that can help you take your time-based calculations to the next level. We'll be exploring 12 essential functions, including DATEDIF, DATEVALUE, DAYS, DAYS360, EDATE, EOMONTH, NETWORKDAYS, NETWORKDAYS.INTL, TIMEVALUE, WORKDAY, WORKDAY.INTL, and YEARFRAC. These functions are perfect for handling business dates, deadlines, and scheduling tasks with precision. So, let's get started and learn how to make the most of these advanced features in Excel. Let's start by exploring the DATEDIF function. The DATEDIF function in Excel calculates the difference between two dates in terms of days, months, or years. The name DATEDIF is a combination of date and difference. This function requires three arguments. Start_date, the initial date of the period you're measuring. End_date, the final date of the period. Unit specifies the type of result you want, such as days, months, or years. I'll explain the different units in the first table shortly. In the first example, we can input the arguments directly into the function. You can see that there are 3 full years between these two dates. In the next example, we'll use the DATEDIF function within a table, directly referencing cells for the start and end date arguments. As you can see, the first two columns contain sample start and end dates. In column D, the unit Y is used to calculate the number of full years between the two dates. By referencing the appropriate cells and using Y as the unit, the function will return the total number of completed years between the dates. In the following column, we will use M as the unit. The M value calculates the number of full months within the period. In the first row, you'll notice the result shows 3 years, but 38 months for the months calculation. This is because, as mentioned earlier, the DATEDIF function calculates completed years separately, which is why the months include the additional months. The next step is calculating the number of days between two dates. Similar to before, we will select the start date and end date as arguments, but this time we'll use D for the unit. This will return the total number of days between the two dates. Alternatively, you can simply subtract the start date from the end date to get the same result, as both methods will yield identical outcomes. In the next steps, we'll explore more of DATEDIF's features. For instance, if you want to calculate the difference in days between the start and end dates, but ignore the months and years, you can use MD as the unit. This will return only the difference in days between the two dates, without accounting for the months or years. The next unit option we'll use is YM. This calculates the difference in months between the start and end dates, while ignoring the days and years. It returns only the difference in months, without considering the days or years between the two dates. So, while the difference between two dates in first row is 3 years and 2 months, there are also 15 days remaining. The function returns 2 completed months. In the next column, we'll apply the YD option as the unit in the DATEDIF function. This calculates the difference in days between the start and end dates, ignoring the years. If the start date falls after the end date in terms of months, it counts the days from the later month to the earlier one. For example, in the third row, the function disregards the years 2018 to 2022 and compares December 12th to July 25th within a single year. The number of days from December 12th to July 25th in the following year totals 225 days. In the next table, we'll tackle a different task, calculating people's age in years, months, and days. However, this formula can be adapted for other purposes, such as project durations, employee tenure, or any other time-related task. For this, we will use the today function as the end date in the DATEDIF function to calculate the difference up to the current date. As before, we'll use Y 4 years, M 4 months, and D 4 days as the unit argument. Let's explore another example to practice the DATEDIF function. For this, we'll reuse the start and end dates from the previous task. In this formula, we're utilizing DATEDIF to calculate the time difference between two dates, broken down into years, months, and days. The formula first determines the number of complete years, then calculates the remaining months, and finally the leftover days. By breaking down the time period into these components, you get a more detailed view of the difference between the two dates, which is then presented in an easy-to-read format. This approach is useful for tracking durations in various contexts. Next, let's explore the DATEVALUE function. The DATEVALUE function converts a date stored as text into a serial number that Excel recognizes as a valid date. This function requires just one argument, date_text, the text that represents a date in an Excel-recognized format. You can either input the text directly or reference a cell containing the date in the correct format. For example, inputting the current date returns the value 45576. In Excel, dates are stored as serial numbers, where January 1st, 1900 is represented by 1, and October 11th, 2024 is serial number 45,576, as it's 45,576 days after January 1st, 1900. In the sample table, we reference cells containing text dates. The last example results in a hashtag value error because the date doesn't exist. Copying valid dates and pasting them into a date-formatted column displays the correct dates. Excel assumes defaults for missing day or year values. Omitting the day sets it to the first, and if the year is missing, it uses the current year. First, we delete the year from B6, and the function updates it from 2023 to 2024. Then, we delete the day from B8, and the day changes from 25 to 1 when entered into D8. The next function we'll learn is DAYS. The DAYS function returns the number of days between two dates. As shown in the syntax, it requires two arguments, the end date, first, and the start date, second. Excel stores dates as sequential serial numbers, which allows them to be used in calculations. You can directly enter dates as arguments. If you input a date directly into the function, it must be enclosed in quotation marks. However, in the sample table, we'll reference the dates from cells. First, we will choose C2 as end date, then B2 as start date. If we simply subtract the start date from the end date, we'll get the same result. However, unlike a basic subtraction formula, the DAYS function can also handle dates entered as text, as long as Excel recognizes the format. Depending on your task, you can use other functions as arguments. For instance, we can use the today function to calculate how many days have passed since a task ended. We explained the DAYS function simply. In upcoming videos, we will use it in complex tasks. The next function is DAYS360. This function calculates the number of days between two dates based on a 360-day year, which assumes 12 30-day months. It's commonly used in accounting calculations. The syntax consists of two required arguments and one optional argument. Start_date and end_date are mandatory, representing the two dates between which you want to calculate the number of days. Method is optional. It determines the day count method. If set to false, the default, it follows the US method. If set to true, it uses the European method. In the US method, if the start date falls on the last day of a month, it is treated as the 30th of that month. If the end date is the last day of the month and the start date is before the 30th, the end date is treated as the first of the next month. Otherwise, the end date is treated as the 30th of that month. In the European method, any start or end date that falls on the 31st of a month is automatically adjusted to the 30th of that same month. You can either select the arguments from cells or enter them directly. If entering the dates manually, using the date function ensures the correct date format. In this example, we'll demonstrate both approaches. Since the dates involve full months, the results will be the same for both methods. In the sample table, we'll reference the arguments from the cells. First, we'll use the US method to calculate the number of days between the two dates. Using the US date format, this will calculate the number of days between the two dates. In the next column, we'll calculate the days using the EU method by setting the method argument to true. The result will be based on the European date format. By comparing the two columns, you can clearly see the difference between these two methods. Let's explore the EDATE function. EDATE calculates the date that is a specified number of months before or after a given start date. The function takes two arguments. Start_date, the initial date from which you want to count. Months, the number of months to add or subtract. A positive value adds months, while a negative value subtracts them. Let's start by using positive numbers to find dates after a given date. Notice the first date and its corresponding result. It shows the date that is 3 months after the date in cell B2. All dates in column B are shifted forward by the number of months specified in column C. As mentioned earlier, if the months argument is negative, the EDATE function will return a date that is the specified number of months before the start date. For example, using -2 for the months argument will shift June 30th back 2 months to April 30th. To move by years using the EDATE function, you can either directly enter the number of months corresponding to the desired number of years or multiply the number of years by 12. To illustrate, let's place a multiplication symbol in front of the number of years. You'll notice that 24 and 2 by 12 produce the same result. You can adjust the months argument as needed. For instance, to calculate a year and a half, multiply 12 by 1.5. For 10 years, multiply 12 by 10. Let's solve the task using the EDATE function in a formula. We have sales data that includes sales dates, amounts, and other information. Our goal is to find the sales amount for each month. First, we'll adjust the format of the result table. We only need to display the month name, so we'll modify the format using the custom option under the number format settings. For this task, I will use the SUMIF function. The sum range will be the amount column. It's important to note that in the result table, the months are represented by a single date, specifically the first day of each month. In the next step, for the first criterion, we will compare the date in the row data to ensure it is greater than or equal to the date in the result table. For the second criterion, the date in the row data should be less than the result of the EDATE function, as the EDATE function will return the first day of the next month. This formula will then calculate the total sales for each month. This is just one application of the EDATE function. There are many other tasks where it can be useful. Let's consider another sample task. Imagine we have credit payments on a given date, and we need to generate the same date for the next 12 months. First, we'll reference a cell that contains the start date. To generate the months, we'll use the sequence function. To cover the next 12 months, we'll set the inputs to create 12 rows and 1 column, starting from 0, which represents the given month. This will allow us to generate the dates for the same day over the next 12 months. Instead of using a cell reference, we can directly enter the date by using the date function and specifying the date within the function. In contrast to the EDATE function, the EOMONTH function returns the serial number for the last day of the month, a specified number of months before or after a given start date. The EOMONTH function takes two arguments. Start_date, this is the starting date you want to calculate from. Months, the number of months before or after the start_date. A positive value moves the date forward, while a negative value moves it backward. Now, let's look at some examples. First, we'll enter a date using the date function. Set the start date to October 1st and the months argument to 1. The function adds 1 month and returns the last day of that month, October 31st. If we change the months argument to 2, it will add 2 months. Let's take a look at a sample table. Here, we'll reference cells for the function's arguments, the start date column for the first argument and the months column for the second argument. We'll begin by using positive numbers for the months. This will calculate a new date by adding the specified number of months and returning the last day of the resulting month. Look both columns, and you will see the difference. Next, let's explore using negative numbers for the months argument. This will generate new dates by moving backward from the start date. For example, using -2 will shift the start date back by 2 months and return the last day of that month. The same logic applies for other negative numbers. We can also shift dates by years using the months argument. To move forward or backward by years, simply multiply the number of years by 12. For example, to move 2 years ahead, use 24 months. Alternatively, we can multiply 12 by the number of years we want to move the date. For example, to move the date by 2 years, simply use 12 by 2. Using the today function, we can easily find both the last and first days of the current month. To get the last day of the current month, use the today function as the start date and set the month's argument to 0. This means no months are added, and it will return the last day of the current month. To get the first day of the current month, use the today function as the start date and set the month's argument to -1. This will return the last day of the previous month. By adding 1 to that result, you'll get the first day of the current month. Now, let's look at another example using the EOMONTH function along with other functions for a deeper understanding. Imagine we need to find the last day of each month over a 12-month period. This can either start from a given date or cover the months from January to December. First, we'll reference a cell that contains the start date for the start_date argument. For the months argument, we can use the sequence function to generate 12 consecutive months. Alternatively, you can directly input a date using the date function for the start date, and you'll see that it returns the last day of each of the 12 months. Our final task for this video involves using the EOMONTH function to calculate total sales for each month. Imagine we have sales data, and we need to sum the sales amounts for each month. For this, we'll use the SUMIFS function along with EOMONTH. First, we type SUMIFS. For the sum range, we select the amount column and fix the range. For the first criteria, we'll specify that the sales date column must be greater than or equal to the first day of the month, which is in the month column. The months in this column represent the first days of each month. For the second criteria, we select the sales date column again, but this time the criteria is that the date must be less than or equal to the result of the EOMONTH function. The EOMONTH function takes the value from the month column, adds 0 to it, and returns the last day of that month. In conclusion, this formula will calculate the total sales amount between the first and last days of each month. The next function we'll learn is NETWORKDAYS. This function calculates the total number of working days between a start date and an end date, excluding weekends and any holidays you specify. It requires 2 main arguments, the start date and the end date. There's also an optional third argument for holidays, where you can specify any dates you want to exclude from the count. Let's begin with some sample tasks. We have a 1-column table that lists the holidays in 2024, and we'll use this holiday data in a few of the tasks. First, we'll calculate the number of workdays in 2024, excluding only weekends. We'll input the start and end dates using the date function to define the full year. As a result, we can see that there are 262 workdays in 2024, excluding only weekends. In the next step, we'll calculate the workdays in 2024, excluding both weekends and the holidays listed in our 2024 holiday table. As before, we'll input the first 2 arguments using the date function, and for the holiday argument, we'll reference the holiday table. As a result, it will return the number of workdays in 2024, subtracting both weekends and holidays. This can be useful for calculating an employee's working days in a year or for other similar tasks. We get 249 working days in 2024, accounting for both weekends and holidays. The holidays in this example are just a sample. You can adjust them based on the holidays in your own country. In the next sample task, we will reference cells for both the required and optional arguments. As a result, we will obtain the number of working days between the specified dates, excluding weekends and the designated holidays. To see the difference, we can calculate the workdays by excluding only weekends. For this, we simply won't reference the holiday cells. We can see that there is a difference of 1 value between the 2 columns, which accounts for the holidays. For this function, let's explore another sample task. Suppose we need to calculate the working days for each month separately. For this task, we'll utilize the holidays table along with the EOMONTH function. The months are represented by the first day of each month and displayed as their respective month names. For the start date argument, we will directly reference the cell containing the month. For the end date, we will use the EOMONTH function, which takes the month as the start date and adds 0, giving us the last day of each month. Finally, we will reference the holidays column for the holidays argument. Here are the results. It provides the number of workdays for each month separately. The next function is NETWORKDAYS.INTL. This function differs slightly from NETWORKDAYS. While both return the number of whole workdays between two dates, NETWORKDAYS.INTL offers the flexibility to specify which days of the week should be considered weekends. The start date and end date arguments are required, while the weekend and holiday arguments are optional. To configure weekends, the function provides two options. You can input a 7-character text string, where 0 represents workdays and 1 represents weekends. Alternatively, you can use predefined numbers that correspond to different weekend combinations, as shown in the table on the left. The number you choose will determine which days are treated as weekends. Now, let's look at the first sample task to practice using the function. We will reference the given cells in the table to select the appropriate options. For the weekend argument, let's start by trying 1, which means that both Saturday and Sunday will be considered weekends. If we leave this argument blank, it will default to 1, treating Saturday and Sunday as weekends. This will result in 8 working days, excluding Saturday, Sunday, and any holidays. In the next column, we'll try different weekend options. If we input 5, Wednesday and Thursday will be treated as weekends. If we input 17, as shown in the table, only Saturday will be considered a weekend. For me, it's easier to remember using the 0 and 1 method. Our next task is to calculate the working days using NETWORKDAYS.INTL. The month is initially given as the first day, but we customized it to display the month name. For the start date, we'll reference the first day of the month. For the end date, we'll use the EOMONTH function, which takes the first day of the month as input, and by adding 0, it returns the last day of that month. For the holiday argument, we'll reference the holidays column for that year and fix it. For the weekend argument, we'll first use 1, Saturday and Sunday as weekends, and then use 11 for comparison. You can adjust these settings to fit your actual task. The next function is TIMEVALUE. The TIMEVALUE function converts a time represented as text into a valid Excel time serial number. The result will range from 0 to approximately 1. Maximum value is less than 1, where 0 represents 12 a.m. and 0.99988 represents 11:59 and 59 seconds p.m. The function requires one argument, time_text, which is a text string representing a time in any of Excel's time formats. You can enter the time value directly into the function, but it's important to enclose the text string in double quotation marks. For example, both midnight and 2400 hours return 0. 12 o'clock returns 0.5. It's important to specify AM or PM correctly, as the result will differ. For instance, 6 o'clock returns 0.25. Excel assumes AM, but 6 p.m. returns 0.75. Let's display the functions in front of the results. It will make the explanation clearer for you. Press FN plus F2 or simply F2, and you'll be able to see the functions directly. Another option for input arguments is referencing cells. However, the values in the reference cells must be in text format. Simply reference the cell, and it will return the proper Excel time. The WORKDAY function returns a number representing a date that is a specified number of working days before or after a given start date. It has 3 arguments, with 2 being required. The first required argument is start_date, which represents the beginning date. The second required argument is days, specifying the number of non-weekend and non-holiday days before or after the start date. The third argument, holidays, is optional and is a list of 1 or more dates to exclude from the working calendar, such as public holidays or floating holidays. We can either input values directly or reference cells. When entering values directly, we can use the DATE function. First, we'll calculate the next working day after 5 working days without accounting for holidays. Then, we'll include a holiday and observe that the date shifts by 1 day. In the next sample task, we will use cell references as arguments. First, we will reference the 2 required arguments and calculate the next working day after the specified number of working days. In the next step, we will add holidays for comparison and the function will exclude non-working days and weekends, providing us with the next working day. In the next column, let's add the number of days to the date. This result will not exclude non-working days or weekends. In the next sample table, we have January 1st, 2024 as the start date, and we will calculate the next working day after 30 and 60 days, excluding non-working days such as holidays and weekends. We will reference a column listing holidays in 2024 for all rows. The WORKDAY function is useful for calculating invoice due dates, expected delivery times, or the number of working days completed. Next, let's explore the WORKDAY.INTL function. This function returns the serial number of a date that falls a certain number of workdays before or after a specified date, allowing for custom weekend settings. The weekend parameters define which days of the week are treated as weekends. Both weekends and holidays are excluded from the calculation of workdays. The function has 2 required and 2 optional arguments. Start_date required, the starting date for the calculation. Days required, the number of workdays to add or subtract from the start_date. A positive value returns a future date, a negative value returns a past date, and a 0 value returns the start_date. Weekend, optional, specifies which days of the week are considered weekends and are excluded from workdays. This can be a weekend number or a string that defines the weekend days. Standard weekend codes are shown in the table to the left. Holidays, optional, a range of 1 or more dates to be excluded from the workday calculation, such as public holidays. These can be provided as a cell range containing the dates or as an array of serial date values. We can either input values directly into this function or reference cells that contain the appropriate arguments. For the first argument, we use the date function. We set days to 5, use the standard weekend code 1, Saturday and Sunday, and specify October 24th as a holiday. The result will return the next working day after 5 workdays, considering Saturday and Sunday as weekends. We have a sample table to practice the WORKDAY.INTL function using cell references for the arguments. For the weekend, we use standard code 1, which considers Saturday and Sunday as the weekend. The function will return the next working day based on the provided arguments. For example, the working day after January 2nd, adding 5 workdays, is January 10th. The function excludes weekends and holidays in the calculation. In the next column, we will use 12 as the weekend argument, which will treat only Mondays as weekends. Refer to the weekend standards for more details. For the weekend argument, we can use combinations of 0 and 1, where 0 represents a working day and 1 represents a weekend day. For example, for the standard weekend setup, Saturday and Sunday as weekends, we would use 5 zeros for the weekdays and 2 ones for the weekend. In the next sample, we will use a column of holidays for the holiday argument. You can adjust the weekend standards according to your daily tasks. This function is useful for calculating invoice due dates, expected delivery times, or the total number of working days completed. The YEARFRAC function computes the portion of a year that is represented by the total number of days between 2 given dates. It accepts 3 arguments, with 2 being mandatory and 1 optional. The start date and end date are required, while the basis is optional. If no value is provided for the basis, the function will default to using 0 as the basis. The result of calculating the difference between 2 dates in the YEARFRAC function will vary depending on the basis value used, as each basis follows a different day count convention. These conventions are outlined in the table. For example, both basis 1 and 4 assume 30 days per month and 360 days per year. However, the key difference between them is how they handle months ending on the 31st. In basis 4, if the end date falls on the 31st, it is treated as the 30th. If both the start and end dates are on the 31st, the end date is also adjusted to the 30th. Basis 1 considers the actual number of days, so in a leap year, it will account for 366 days. As shown in the table, basis 2 assumes a 360-day year, while basis 3 assumes a 365-day year. We can input dates directly in double quotation marks when using the YEARFRAC function. If the basis is omitted, Excel will automatically assume basis 0. For example, the period between January 1st and March 30th represents approximately 0.25 of a year under this default setting. Let's review the sample table and calculate the fraction of the year between the dates for each basis. We will calculate the year fraction from January 1st, 2024 to the last day of each month, and we will perform the calculations for all basis options separately to observe the differences. Due to variations in the number of days in a month or year, the results for the same date will differ across each basis. Let's calculate the percentage of the year that has passed and the percentage that remains. We'll use the date, year, and today functions together with YEARFRAC. The year function will extract the current year from the today function, which will serve as the first argument for the date function, setting the start date for YEARFRAC. The end date will be the current date from the second today function, and we'll use 3 as the basis. The result will show the percentage of the year that has passed. To find the remaining percentage, we will subtract this result from 1. That's it for today's video. I hope you found these advanced date and time functions helpful for managing your data and simplifying complex calculations in Excel. Whether you're working with project timelines, business schedules, or financial deadlines, these functions can really streamline your workflow. If you enjoyed this video or learned something new, don't forget to like, subscribe, and hit the notification bell so you never miss out on future Excel tips and tutorials. Thanks for watching, and I'll see you in the next video.